It's QIDI's newly launched 3D printer, the Q2C Combo, that includes their new multi-material filament system called the QIDI Box, a better value than their Q2 Combo? That's what we're going to find out in this video. Hi, I'm Ken of Wrist Innovations, and welcome to today's video to take a peek under the hood of the newly launched QIDI Q2C Combo 3D printer and compare it to their recently launched Q2 Combo printer. No, you're not seeing double vision. The Q2 and the Q2C look very similar. I'll cover the initial prints, features, unboxing, cost, and the pros and cons of both printers, so you can make an informed decision on which model 3D printer you may want to consider buying. I have organized the video into chapters listed in the description that will allow you to skip around the video depending on what is important to you. I want to thank QIDI for sending me the Q2C Combo for my evaluation. Okay, let's get started. Let's first start with the most important part of evaluating a 3D printer, and that's the quality of the parts. I printed parts using PLA, PETG, TPU, ABS, glass-filled ABS, and carbon-filled nylon, and I think you're going to be surprised at the results. First, I printed a preloaded design of the benchy in PLA on both printers. For the Q2, the benchy turned out overall very nice. For the Q2C, the benchy turned out similar to the Q2. It had a few more stringers, but overall it looked similar to the Q2 benchy. Next, I printed this calibration test designed by Gabox 3D on printables using PLA. For the Q2C, the overhang test successfully printed all the way to 80 degrees. At 60 degrees, there were a few lines that were drooping, but other than that, it looked good.
The various cylinder diameters measured 9.83 millimeters, 7.82 millimeters, 5.80 millimeters, and 3.95 millimeters versus design diameters of 10 millimeters, 8 millimeters, 6 millimeters, and 4 millimeters respectively. The various rectangle lengths measured 10.12 millimeters, 20.06 millimeters, and 30.07 millimeters for design lengths of 10 millimeters, 20 millimeters, and 30 millimeters respectively. Bridging overall looked good, and there were only a few stringers on the Q2C part. For the Q2, the overhang test also successfully printed all the way to 80 degrees. The various cylinder diameters measured 9.89 millimeters, 7.90 millimeters, 5.87 millimeters, and 3.84 millimeters versus design diameters of 10 millimeters, 8 millimeters, 6 millimeters, and 4 millimeters respectively. The various rectangle lengths measured 10.13 millimeters, 20.11 millimeters, and 30.26 millimeters for design lengths of 10 millimeters, 20 millimeters, and 30 millimeters respectively.
Bridging overall looked good, and there were little to no stringers on the Q2 part. The calibration test results were really similar for both printers. Next, I printed a spiral vase design using PETG that was uploaded to printables by Max413049. However, the original design is by Big Bad Bison on Thingiverse.com. For the Q2, I used basic PETG and the vase turned out well. It did have a few random defects, but overall it was a nice part. For the Q2C, I used a translucent PETG, so it's not an exact comparison, but I really wanted to see how the translucent PETG turned out. I think it turned out beautiful. It appears that both printers can handle PETG without any problem. Do you remember telling me about a product you designed, but that you didn't have a 3D printer to make it? Well, let's go upstairs to grab a cup of coffee and talk about it. Here's your coffee. I have a way for you to get your product design made even if you don't have a 3D printer. The sponsor of today's video, PCBWay, is your solution. You can go to PCBWay's website, upload your STL file, and they can make it and ship it right to your door. If your project needs other parts made, PCBWay can also provide PCBs and PCB assemblies, CNC machining, sheet metal fabrication, and injection molding. I have personally used their services to 3D print a stainless steel insert for a high wear application. Their customer service and quality of parts are excellent. There's a link in the description below, and they will even provide you with a $5 welcome bonus. Thank you, PCBWay, for sponsoring today's video. Now, let's head back downstairs to the workshop. Next, I printed this truck tire out of TPU, designed by Elmcom 193290 on printables. Since TPU can be stringy, I dried the spool of TPU in my Sunlu filament dryer at 55 degrees C for 6 hours. For both the Q2 and the Q2C, the TPU truck tires turned out great. There was very little stringing on the parts. Okay, so now let's step up our game with a more challenging material, ABS. ABS can be a challenge because it tends to easily warp when printing because it really needs a warm environment. Here's one of the first differences between the Q2 and the Q2C. The Q2 has an actively heated chamber heater that can reach 65 degrees C. However, the Q2C does not have this feature. I printed this vice grips tool design by 3dprintedhardware.com. I did use a brim and support because there are a lot of overhangs and some of the parts did not have much contact with the build plate. I was really happy with the results from both the Q2 and the Q2C because the vice grips turned out beautiful. None of the parts had any warping and both completed tools worked really well. Even though I'm not a big fan of multicolor printing due to the amount of wasted filament and how slow the prints take, I thought it was important to test the multi-filament capabilities of the QIDI box. So I had to try a multicolor print. I printed this articulated Rexicon, which is Trex plus Dragon Flexi, by Pinky Wings on MakerWorld in 3 colors of PLA. Both printers took approximately 8 hours to print, and they created a lot of filament waste, as most single nozzle multicolor prints do. For this part, the print itself used approximately 21 grams of filament, but it generated 115 grams of waste. This is a good time to mention that QIDI made several improvements to the QIDI box since I received my original one with the Q2. The latest version of the QIDI box includes a filament accumulation module mounted on the back of the printer, and a removable panel in the bottom that allows easier access if you need to remove a broken filament from the QIDI box. For the Q2C version of the Rexicon, there seems to be some of the black contamination with the orange and the white, so it appears there wasn't enough purging between colors. But that should be an easy fix with the slicer. Other than that, both printers produced an excellent multicolor print. So, now let's get wild and crazy and print a part using glass-filled ABS. QIDI recommends that you dry your glass-filled ABS before printing, so this will give me a chance to test the QIDI box drying feature. I placed the spool of glass-filled ABS in the QIDI box and set the drying temperature to 65 degrees for 8 hours per QIDI's default settings. Quick note, the QIDI box's maximum drying temperature is 65 degrees C. A feature of the drying cycle is that the QIDI box rotates the spool every 5 minutes for a more even heating. Also, there's a manual vent on the back to open up and let out the moist air, but you need to remember to close it after the drying cycle is completed. I decided to print these channel lock pliers designed by 3dprintedhardware.com. I did use a brim and support because there's a lot of overhangs and some of the parts did not have much contact with the build plate. I was really happy with the results from the Q2 because the pliers turned out great. None of the parts had any warping and the completed tool worked really nicely. For the Q2C, I did have some slight warping on one of the handles, but overall the quality of the print was similar to the Q2. Now, do you want to get totally nuts? How about printing a nylon carbon-filled part? Nylon is very susceptible to warping and is very sensitive to absorbing moisture. So, it's recommended to dry PA12 carbon-filled at 90 degrees C. I placed the spool in my Sunlu dryer for 2 hours because the QIDI box can only reach 65 degrees C. Then I printed this pipe wrench designed by 3dprintedhardware.com. For the Q2, the pipe wrench turned out excellent. There was absolutely no warping and the pipe wrench works well. For the Q2C, the pipe wrench also turned out excellent with no warping and it also works well. So I really didn't see a difference between the Q2 versus the Q2C pipe wrenches. So, to summarize the parts quality section of this video, based on my experience, the QIDI Q2 and the Q2C produce high-quality printed parts that rival the quality of prints that I get from my top printers, such as the Bamboo series of printers. Now, let's cover the main features and the differences between the QIDI Q2C Combo versus the Q2 Combo. The QIDI Q2C is really a Q2 with a few missing features. So there are a lot more features that are the same between the two model printers. First, I'll cover what both printers have in common, then I'll cover the differences. Both printers have an overall printer dimensions of 402 millimeters wide by 438 millimeters deep by 494 millimeters high. And the QIDI box has overall dimensions of 357 millimeters wide by 300 millimeters deep by 234 millimeters high. Initially, when the Q2 was launched, QIDI recommended that when you were printing PLA to place the QIDI box next to the printer and open up the top at least halfway. The adjustable glass top was nice, but I wasn't a big fan to have the QIDI box sit next to the Q2 and take up so much precious shelf space. QIDI has since included a spacer for the QIDI box that allows more clearance for the printhead Teflon tubing, and now I open up the top glass plate with the QIDI box on top of the printer. This is how QIDI is shipping both the Q2 and the Q2C printers today, with this riser. Both printers weigh 18 kilograms, and the QIDI box weighs 4 kilograms for a combined weight of approximately 22 kilograms. The Q2 and Q2C print volume is 270 millimeters by 270 millimeters by 256 millimeters. They are both fully enclosed Core XY printers made from a rigid internal metal frame and a glass top and door. They have X linear guide rails and a 1.5 gear tooth belt, which QIDI claims offers smoother motion. Both printers have a maximum hot end temperature of 370 degrees C and a maximum build plate temperature of 120 degrees C. They both have a maximum speed of 600 millimeters per second and a maximum acceleration of 20,000 millimeters per second squared. They both have a nozzle wipe feature. Both printers have a new nozzle sensor that is unaffected by the bed surface material, and in fact, QIDI has a video showing how they printed on fabric, marble, glass, and even wood, which is pretty impressive. Both the Q2 and the Q2C have multicolor filament multi-material capability when using their new QIDI box. The QIDI box can recognize the RFID tags in the QIDI filament spools that allow the QIDI box to recognize the color and specific material of each spool. Each QIDI box unit can hold 4 spools of filament, and you can connect as many as 4 QIDI box units to the printer for a maximum of 16 colors. The QIDI box is one of the few multi-material modules on the market that have filament drying capabilities, which can dry filaments up to 65 degrees C. Just as with other multi-material modules, the QIDI box cannot be used with TPU, PETG, and other very rigid or flexible materials. They both come with an auxiliary parts cooling fan and a textured PEI build plate. They both work with the QIDI Studio Slicer. They both can print wirelessly using the QIDI Studio Slicer, and they can print in LAN mode. They both have auto bed leveling, Z-axis offset, power loss recovery, and an internal LED light. You can print the following filaments on both printers: PLA, PETG, TPU, ABS, ASA, PA, PC, and carbon-filled or glass-filled materials. Both printers have a 4.3-inch color touchscreen to interface with the printer. You can transfer files using a USB drive for both printers. QIDI has stated the Q2 family is the first 3D printer to obtain the US MET Product Safety Certification. The MET certification means a product has been certified by MET Labs to meet applicable safety standards in the US and Canada. MET Labs is a nationally recognized testing laboratory. Here are some of the differences between the printers. They both have a filament runout sensor and a chamber fan. However, the Q2 ships with a carbon and HEPA filter, while that's an option for the Q2C. Another key difference is the Q2 has an actively heated chamber that can reach 60 degrees C, while the Q2C does not have this feature. The Q2 has a 1080p resolution camera that offers AI detection. However, the camera is an option for the Q2C. Now, let's unbox and set up the Q2C. It's identical to set up the Q2C as it is for the Q2. Once you remove either printer out of the box, it's just a matter of removing the various foam packaging from the printer and opening the 2 accessory boxes. The accessory boxes contain the toolkit, Ethernet cable, power cord, scraper, filament holder, and screwdriver. The top of the box contains the glass top, the filament holder arm, and the touchscreen. Remove the QIDI box from inside the printer by removing 2 screws in the front and lifting the QIDI box out of the top of the printer. Remove the riser parts and various foam pieces. Next, cut and remove several cable ties. Loosen 4 screws and remove the QIDI box shipping support. Attach the touchscreen to the ribbon cable in the front of the printer and snap the touchscreen in place. Loosen 4 screws that are holding the build plate to the printer. Cut the cable ties from the X-rail and remove the cardboard from the tool head. Assemble the glass top riser and install it on top of the Q2C. Install the glass top. Unpack the QIDI box. The QIDI box will contain cables to connect to the Q2C, a power cord, and a filament hub. Attach the box hub to the back of the Q2C. Connect the 4 PTFE tubes to the box hub and to the QIDI box. Connect the PFE tube from the Q2C to the outfeed of the box hub. Plug the 8-pin end of the signal cable into the Q2C and the 4-pin end into the QIDI box. Plug the 8-pin end of the box hub cable into the QIDI box and the other end into the box hub. Attach the power cords to the Q2C and to the QIDI box and plug them into an electrical outlet and turn on the printer and the QIDI box. Follow the screen prompts by choosing a language and follow the instructions, including removing the foam from underneath the build plate. The printer will perform a self-inspection and then input shaping and auto bed leveling. Load some filament into the QIDI box unit. I also uploaded QIDI's latest slicer software on my computer. Finally, I was ready to print my first part. Now, let's compare the cost of the Q2C combo and the Q2 combo. At the making of this video, December 2025, the QIDI Q2 without the QIDI box cost is $499. The QIDI Q2 combo with the QIDI box cost is $649. The QIDI Q2C without the QIDI box cost is $399. The QIDI Q2C combo with the QIDI box cost is $549. So the Q2C is $100 less, both for the printer by itself or as a combo with the QIDI box. So what's missing from the Q2C? The Q2C does not include a camera, air filter, or actively heated chamber. For the Q2C, you can buy the optional camera for $40 and air filter for $10. So that means the missing actively heated chamber is valued at around $50. As a comparison, the Bambu Lab P1S without the AMS is on sale for $399 and $549 with the AMS and $639 with the AMS2 Pro. The new Bambu Lab P2S 3D printer cost is $549 and the P2S Combo with the AMS2 Pro cost is $799. So, the Q2 combo is $10 more than the P1S combo with the AMS2 Pro, and the Q2 combo is $150 less than the P2S combo with the AMS2 Pro. Now, let's go to my pros, cons, final summary to see if spending $100 less for the QIDI Q2C combo is worth it versus buying a QIDI Q2 combo. Overall, I'm impressed with the quality of the prints I made on both the QIDI Q2 and the Q2C printers, including prints made from ABS and carbon-filled nylon. For a variety of parts, I consider the print quality to be comparable to the quality from the Bambu Lab P1S. The Q2 and Q2C have a print volume of 270 millimeters by 270 millimeters by 256 millimeters. They have a maximum print head temperature of 370 degrees C, which is especially great for engineering materials. The Q2 and Q2C are fully enclosed Core XY printers made from a rigid internal metal frame, and they have a glass top and door. They have X-axis linear guide rails and a 1.5 gear tooth belt, which QIDI claims offers smoother motion. They have a maximum build plate temperature of 120 degrees C, and they have a maximum speed of 600 millimeters per second and a maximum acceleration of 20,000 millimeters per second squared. They both have a filament runout sensor and a chamber fan. However, only the Q2 is shipped with a carbon and HEPA filter, while the air filter is optional for the Q2C. The Q2 and Q2C have a new nozzle sensor that is unaffected by the bed surface material, and in fact, QIDI has made a video showing how they can print on fabric, marble, glass, and even wood, which is pretty amazing. The Q2 has an actively heated chamber that can reach 60 degrees C. However, the Q2C does not have this feature. Both the Q2 and Q2C have multi-color filament, multi-material capability when using their new QIDI box, and you can link them together for up to 16 colors. The QIDI box is one of the few multi-material modules on the market that have filament drying capabilities, which can dry filaments up to 65 degrees C. They both come with auxiliary parts cooling fans and a textured PEI build plate. Both printers can print wirelessly using the QIDI Studio Slicer and can print in land mode. Both printers have auto bed leveling, Z-axis offset, power loss recovery, and an internal LED light. You can print the following filaments on the Q2 and the Q2C: PLA, PETG, TPU, ABS, ASA, PA, PC, and carbon-filled or glass-filled materials. They both have a 4.3-inch color touchscreen to interface with the printer. The Q2 has a 1080p resolution camera that offers AI detection. However, the camera is optional for the Q2C. QIDI has stated in their literature that the Q2 is the first 3D printer to obtain the US MET Product Safety Certification. Now the cons. I understand that QIDI was trying to reduce the price of the Q2 by offering a stripped-down version, resulting in the Q2C. However, removing the air filter and camera don't seem like a viable option, at least to me, because I want the option to filter the air for my health, and so many 3D printers ship today with cameras as standard, I really miss the remote monitoring that a camera provides. From my experience, an actively heated chamber is nice to have, especially for higher temperature engineering material, and I believe that an actively heated chamber provides a larger process window and improves your odds in having a successful 3D print, especially for higher temperature engineering materials. Although I have found that I have been able to successfully print many engineering materials without an actively heated chamber, it's always nice to have that extra safety factor by having an actively heated chamber. So, for me at least, it's worth the extra $100 for the QIDI Q2 versus the Q2C. Based on that, I've already ordered an air filter and camera for my Q2C as an upgrade, and I'll just live without the heated chamber. My overall impression is that both the QIDI Q2 and Q2C are worthy competitors to the Bambu Lab P1S and possibly the P2S. However, I have not evaluated my P2S yet. That video will be coming soon. I think it is worth the extra $100 to have an air filter, camera, and actively heated chamber in the Q2 versus not having those features in the Q2C. I think for somebody on a budget, buying the Q2 Combo at $649 is a good value versus the $799 for the Bambu Lab P2S Combo. What do you think? Which of these printers would you buy between the Q2, Q2C, P1S, and P2S? Let me know in the comments below. If you'd like to see my video titled Elegoo Centauri Carbon Printer, Better Value Than Bambu Lab P1S, that link is here. If you'd like to see my video titled Anycubic Cobra S1 Printer, Better Value Than Bambu Lab P1S, that link is here. Thanks for watching. Bye.